Hello, this is Mr. Huber. In this lesson, we're going to look at adding and subtracting rational expressions, which are fractions. In order to add and subtract fractions, we're going to need to have a common denominator. So first, we're going to see some examples with a common denominator, and then we're going to have to do some work beyond that when we don't have common denominators. But in these first couple examples, we have a common denominator. So in order to add these, we just add or subtract the numerators. So in this first example, we'd add the 7 and 13. That gives us 20 over 6x squared, right? The common denominator just stays the denominator, okay? And now we can look to see if we can reduce this after we add. We can't reduce across the two fractions before we add or subtract like we could sometimes with multiplication or division, okay? So now we want to look at this and we can say, okay, yes, I can reduce this 6 to a 3 and a 20 to a 10, and I get 10 over 3x squared. And I also want to make sure that I look for any restrictions on my variables. In this case, x cannot be equal to 0, because just like when we added, subtracted, and worked with just simplifying rational expressions, I can't have a 0 in either of these denominators. Okay, now I look at number 2, and I still have a common denominator. X minus 2 is the same denominator in both of those fractions. So I can do 4x minus x. No, we're subtracting. 4x minus x is 3x over x minus 2. We cannot reduce this. Do not cancel out the x and the x. X is not a factor in the denominator. So that would be our answer from subtraction. And now we want to look at any restrictions on the denominator, or on the variable based on the denominator. We can't have an x value of 2. Okay? So this would be our answer from the subtraction of the two fractions, right? The difference of them. And then our restriction on the variable, because again, we can't have this denominator equal to 0. Okay, let's look at finding common denominators. Remember, when you find a common denominator, we're going to do one with just a fraction without any variables or anything in it. We want to look at factors of the denominator and figure out how we can get them to be the same. So we want to look at this first example here, 5 over 6 and 2 over 15. 6 can be 3 times 2. And 15 could be 3 times 5. So what factor am I missing in this denominator that I have in this one? Well, this doesn't have a 5 as a factor. So I would want to multiply this first fraction by 5 over 5. And my second fraction doesn't have a 2 as one of its factors. It's got the 3 and the 5, but it doesn't have the 2, so I'd multiply by 2 over 2. When I do that, I get 25 over 30 plus 4 over 30. Okay? And so now I have a common denominator. I can add these and get 29 over 30. I don't have to worry about any restrictions because I don't have any variables to worry about there. So 29 over 30. I can get a common denominator by looking for 3 times 2, 3 times 5. Okay, this one had a 3 and a 3. Those are the same, but the 2 isn't a factor over here yet, so multiply. Numerator and denominator both by 2. 5 is not a factor in this denominator yet, so multiply by 5 over 5. And now when I get the common denominator, I can add the numerators to get my answer. All right. So let's look at how that works with some rational expressions with variables involved. So 4x and 7, okay? So sometimes we just want to multiply by the other denominator. Okay, this doesn't have a factor of 4x in it, so I need to multiply the numerator and denominator both by 4x. And I multiply over here by 7 over 7. Because now, in my denominators, I'm going to get 28x and minus, and this is going to be 28x. So I can see my denominators are going to be the same, right? 7 here times 4x gives me 28x. 7 times 4x gives me 28x. Now I have to multiply the numerators. We're multiplying this whole numerator by 7. So when I do that, I'm going to get 21x minus 14. 21x minus 14 over 28x, and then 16x over 28x. We also need to recognize that we're subtracting. So when we subtract here, we have 21x minus 16x. Those are the like terms that I can actually add and subtract. So that's going to be equal to 15x, okay, minus 14. 15x minus 14 over 28x. And then my restriction is that x cannot be equal to 0 because of this first fraction. I can't have a 0 in that denominator. Over here, there's no worries because there's no variable to even concern ourselves with. So that would be my answer. It's my fraction, 15x minus 14 over 28x, and then my restriction is that x can't be equal to 0. If we look at number 4, we're going to have to factor those two denominators first. So this first denominator we get factored to x minus 4 and x plus 3. And if we factor a 12 out of the second denominator, we end up with 12 and then x minus 4. So if we look, this first denominator, the denominator doesn't have a 12 in it, so I multiply by 12 over 12. The second denominator doesn't have an x plus 3 in it, so I'm going to multiply by x plus 3 over x plus 3. Now my denominators are going to be 12, x minus 4, x plus 3. That's my first fraction. Plus, in my second fraction, we have 12 times x minus 4 times x plus 3. What do you know? They're the same. So now my first fraction, 12 times x, I get 12x in the numerator. Second one, I get 5x plus 15, right? And so now I can add my two numerators, and I get 17x plus 15 over 12 times x minus 4 times x plus 3. You don't need to multiply that all together. You can't. You could if you wanted to. You could FOIL the x minus 4 and x plus 3, then multiply it all by 12, but I would say just leave it like this. And then note our restrictions. We can't have negative 3 or 4 for x values. Negative 3 and 4 are our restrictions. Okay? All right. Before we see a couple more examples, a little peach pit stop. Who is the only baseball player in American League history to hit for 400, an average of 400 is pretty incredible, for a season, 3 different seasons. This guy did it 3 different seasons. He's a former Tiger. You see there, he did it in 1911, 1912, and 1922. Long career, as you can tell there. He actually played 22 seasons with the Detroit Tigers. That is Ty Cobb. He's known as the Georgia Peach because he was from Georgia, born there, so they called him the Georgia Peach. All right, and in 1936, after his 22 seasons with the Tigers, he was elected into the Hall of Fame, the first ballot of the Hall of Fame, the first Hall of Fame class. He was elected, and he had the highest number of votes of anybody that was voted in that year, and he had the highest percentage of votes all the way till 1992. So a really impressive player, considered one of the greats in the game. He set 90 major league records, career batting average of 366, which is awesome to do for one season, let alone for a year. He could hit for average, RBIs, steals. He actually stole home 54 times. Yes, he stole home 54 times. Pretty amazing. He was known to be an aggressive player and off the field a little violent. That's tarnished his image and his legacy a little over the years as people have learned maybe a little more about him. Some of it's overblown if you read some of the factual accounts, but nonetheless, his aggressive style resulted in pretty solid play, and his name is honored at Comerica Park, where the Tigers play. If you look there where the numbers are retired, he didn't have a number retired because players didn't wear numbers then, so it just says Cobb out there on the wall by the other retired numbers. So Ty Cobb, one of the all-time greats, a Detroit Tiger, and quite a hitter for average, speed, and some power. All right, let's look at adding and subtracting a couple more rational expressions. All right, in number 5 here, again, we want to look for any factoring we can do so we can find out what factors we need to include that aren't in either of the denominators. So the first one, 3x squared, can't be factored. We don't need to do anything there. But the second fraction, we can factor the denominator to 3x and x minus 4. Okay? And so now we can look and we can see in that first denominator, we have 3x squared. I don't see an x minus 4 there. So we're going to need to multiply by x minus 4 over x minus 4. Okay? Should be a minus there. All right, and then the second fraction, okay, we need to multiply by x over x because we needed it to be an x squared. We have a 3x there, but not an x squared. Okay? So now we're going to get x minus 4 over x minus 4 times 3x squared plus x times x is x squared, and we'll have 3x squared and x minus 4. It doesn't matter if we write them in the same order or not, we're multiplying. So like 10 times 2 and 2 times 10 are the same. Those denominators are the same because we have the same two factors multiplying each other. So now we can add, right? The x squared doesn't have a common term that it can add with, so we have just x squared plus x minus 4. And that would all be over 3x squared times x minus 4. Doesn't matter. You could write it as the x minus 4 in parentheses and the 3x squared. That's fine. And our restriction on our variables, we can't have a 0 because right here, right, if we put a 0 in here, we'd have 0 squared times 3. We'd have a 0 for denominator. We look at this, we can't have a 0 Okay, we don't need to write it more than once, but we also can't have 4. So we're going to need to include 4 as well. So the x cannot be equal to 0 or 4. That is our answer and our restriction on our variables. Okay, one more here, and some factoring to do before we can figure out any common denominators. So the first part of this is going to factor to x plus 2 and x plus 2. And then over here, we're going to have x minus 2 and x plus 2. It's a difference of squares, okay? So we want to look, those aren't the same. We have an x plus 2 and an x plus 2, but then we have x minus 2 and x plus 2. So we need to multiply each of these by the other one. So in the first denominator, we need to get an x minus 2 in there. So I'm going to multiply by x minus 2 over x minus 2. Okay. And in our second fraction, we're going to have to get another x plus 2 in the denominator. So I got to multiply both numerator and denominator by x plus 2. And so our denominator is going to be this long string of binomials, x minus 2, x plus 2, x plus 2. Minus, and I'm going to write down my denominator here, x minus 2, x plus 2, and I'll write it a little bit below there because I'm running out of room a little bit, x plus 2. Now, in our first fraction, we're going to multiply x minus 2 times 6, so 6x minus 12. So it's going to be 6x minus 12. All right? And then in our second fraction, we need to FOIL these. Okay, and we're going to end up with x squared plus 3x plus 2. Okay, so now we got our common denominator. Now we can actually subtract. So when you subtract these, I'm just going to write our denominator down. It's going to be x minus 2, x plus 2, x plus 2. And we subtract, this is the only term with an x squared, so it's a negative x squared. Remember, a negative x squared. So we want to include that negative x squared, which is subtracting it. Then we have 6x minus 3x. 6x minus 3x is a positive 3x. And then we get negative 12 minus 2, which is a negative 14. Okay? And that would be our final answer with a restriction on the variables of x cannot be equal to plus or minus 2. So when we're adding and subtracting fractions, look to get a common denominator. That means look for factoring and find out what factors you don't have in a fraction. Multiply the numerator and denominator by that factor that you need to include so there can be a common one when you add and subtract the numerators.